Welcome to Inside Labs Education, and now we'll be looking at irrational numbers. Irrational numbers are defined as numbers that cannot be expressed in the form a over b. We know that a over b, or numbers that can be expressed in the form a over b, are rational numbers. That's why numbers that cannot be expressed in the form a over b are not rational, meaning they're irrational. We're going to be looking into that. With our first example being pi. If you have a casio calculator, press shift and the 10 exponent x, or the 10 to the power of x on your calculator, when you press it, after pressing shift, you get pi. Once you press pi, you must press the equal sign on your calculator, then press SD. It will give you a few of the digits of pi. Pi is infinite, it never stops. But like I said in the other video, that a calculator cannot write all the numbers. That's why we have only the few. I'm gonna write the first few so you can see what I'm talking about. And so on. They don't stop. As you can see, the pattern is not repeating, meaning it's not reoccurring, and it's not stopping, meaning it's not terminating. If it's not stopping or not recurring, we cannot write this as a fraction, meaning in the form a over b. Because of that, it is irrational. Next, irrational numbers are not repeating, like I just said, and they're not recurring decimals, like we say. Square roots for numbers that are not perfect. Example, square roots for numbers that are not perfect, like 2, the square root of 5, and the square root of 6. They are irrational numbers. Because if you take your calculator and say the square root of 2, let's look at just the square root of 2. And you press SD, you get 1 comma 4 1 4 2 1 3 5 6 and 2. It continues. Just that the calculator cannot show it. Does not have all the space and ink to do so. It continues. Because of this, we cannot write these numbers the form of a over b without the square root being there. The same applies for the square root of 5 and the square root of 6. The same can be said to cube roots. Cube roots with numbers that are not perfect. Example, the cube root of 3. Let's go. It will be 1 comma 4 4 this 4 4 2 2 4. You get the gyps. It continues. Just that the computer won't show all the numbers. Because of this, it's not occurring and it's non-stopping. It continues. It's infinite. And the pattern, there is no pattern, there is no repeating pattern. So they cannot be written as a common fraction, a over b. Hence they are considered to be irrational. The same applies to 6. They are not perfect. They're not cube roots. Yeah, they're not perfect cubes and they're not perfect squares. Then what are perfect squares? I'm sure this you know. but just in case someone does not know, a perfect square is numbers like 4, square root of 4, square root of 9, because the square root of 4 is 2, the square root of 9 is 3. Get it? Next is the square root of 16, which we know it's 4. Square root of 25, we know it's 5. The square root of 36, we know it's 6, and so on. These are perfect squares. What are perfect cubes? In case someone asks. The square root of 27. Okay, let's start with 8. Let's start with 8. The cube root of 8. The cube root of 27. We know this is just 2, and this is just 3. You can plug it in your calculator, you will see. And the cube root of 64, it's 4. The pattern goes on like so. You will see for yourself. The cube root of 125 is 5. Continues in this pattern. Hopefully you get the picture. Those are perfect squares and perfect cubes. The roots, the square roots, basically this symbol disappears. This thing disappears without any decimals being left behind. That's why they're considered to be perfect. Let us stop here.